Alright, so this video is going to be more of a watch along as you see me step through this problem. It's been a while since I've done electronics. However, I'm trying to get my brain back in order because I'll be doing some electronics in college this semester. So this one has to do with a series parallel circuit like I've done in the last episode. However, the trick of it is resistor value is missing. If you see right here, we do not know the value for this resistor. However, we do know what the current is, and we do know the voltage is, and we know these two resistors. So we should be able to parse it together. Now, I'm just going to step through it, and I'm going to work. And if it's incorrect, it's a part of the process. So, we have our voltage source here. We have our 5 ohms here. We have our resistor here, resistor down here. It joins together. All right, goes down. There. So we have a 20 volt source, 20 volts. The current is going to be 2.2 amps. So let's make a little ammeter right here. And it reads 2.02 amps. We know that one of the resistors is worth 5 ohms. And the other is worth 6 ohms. We do not know what this third resistor is worth. So, like every problem before, let's just write what we're looking for. VT, V1, V2, V3, IT, I1, I2, I3, RT, R1, R2, R3, and PT. P1, P2, and P3. All right. Let's fill out what we know. We know what IT is. IT is going to be 2.02 amps. And that means I1 is going to be 2.02 amps as well. All right. We do not know what I2 or I3 is going to be. We know what R1 is. R1 is 5 ohms. R2 is going to be 6 ohms. We do not know what RT or R3 is. VT is going to be 20 ohms. No, 20 volts. And that's all they give us. So let's first solve for what we know. We know what RT is and we know what IT is, so we can find what VR1 is. To do that, we bring up the triangle, V equal I over R, V I R, and we're looking for voltage. So let's cover the voltage, and it's I times R. I times R is 2.2 amps times 5 ohms. 2.02 amps times 5 ohms is going to be 10.1 volts. All right. So because of that, we can now figure out what V2 and V3 are, because in parallel, the voltage is the same and the current is different. So that means 20 minus 10.1 is going to be equal to 9.9 volts. So that's going to be the value for V2 and V3. 9.9 volts. All right. So And I'm starting to figure out that this is getting a little bit easier as we go along. And sometimes that's the problem. You just need to work what you know, and then what you don't know will come naturally. So, what do we have? We have V2 and we have R2. And it gets its own voltage because it's in parallel, so we can treat it as such. V divided by R equals I, as per the triangle shows. V divided by R equals I. So, dividing 9.9 volts by 6 ohms is going to give us the current. So 9.9 divided by 6 equals 1.65. 1.65 amps. All right. So from there, we can find how much current is going through I3, because the current, we can't add or subtract current. Well, technically, that's what we're doing, but we can't add current. So that means what comes in is 2.02 amps. What comes out has to equal 2.02 amps to show that nothing's been added or taken away in this closed circuit. So the total current is 2.02 amps. And I2 is already draining 1.65 amps away from it. That means that the amount of current that can go through I3 is the sum of, or the difference between 2.02 and 1.65. So plugging that in our calculator, 1.65, we get 0.37 amps. Or 370 milliamps. Okay. 370 milliamps. Okay. So now we can find out what R is. R is going to be the product of voltage and current. So we're going to be dividing 9.9 volts by 370 milliamps. And that's going to give us our resistance. So 9.9 divided by 370, negative 3. That gives us 26.756 ohms. And that's going to be the value for R3. 26.756 ohms. All right. Now let's go further and solve for RT. We see that we have one resistor in series and then two in parallel. So we need to first combine the two that are in parallel by inversely adding them. So it's the inverse of 6 ohms plus the inverse of 26.756, and then we're going to take the inverse of that. So if we do that and then add 5 ohms, that should equal RT. So let's do that. 6 1 over x plus 26.756 1 over x equals 1 over x plus 5. That's going to be equal to 9.90. Well, let's just do 9.9 ohms for RT. Okay, now let's solve for power. And to solve for power, we just do what we've always done. We multiply the voltage and the current. So for PT, and then we're just going to add it up to find PT. All right, here we go. We know the voltage is 9.9 volts for VR3. So we take 9.9 times 370 milliamps, and we're going to get 3.663 watts. Wait, let's just double check that. 9.9 times 370 negative 3. Yep. Now let's do it for V2. 9.9 times 1.65 amps is going to be 16.335 watts. And now 10.1 times 2.02 amps is equal to 20.402. And now let's just add them up. 20.402 plus 16.335 plus 3.663 equals 40.4 watts. Now let's just double check. 20 times. If you take 20 and multiply it by 2.02, what you're going to get is 20 volts times 2.02 amps equals 40.4 watts. And that's going to be my predicted answer. I'm not sure if it's correct. However, we can double check. I think the website has the answer here. And they only ask for the resistance, the missing resistance. But we can look. They don't have it. That's okay. I'm pretty sure that this is correct. And this was more just me testing out more complex problems. And I'm going to move on to maybe working on some things called Thevenin, superposition, nodal analysis. All these things are stuff I'm going to have to know by next week, which is fine. I'm going to learn it anyway, but I just kind of want to review it. So yeah, that's about it. Thank you so much for watching, and I hope you have a great day.